Hi everyone, I'm Doerr. I am in the Tech 880E class, currently working on the low entry, high ceiling task. So the question that we're looking at here is the positive integers a and b are such that the graphs of y is equal to ax plus 5 and y equals 3x plus b intersect the x-axis at the same point. What is the sum of all possible x-coordinates of these points of intersection? Okay, so when I first started looking at this problem, I thought right away, okay, system of equations problem, I'm thinking to go ahead and solve this thing algebraically. And as I dove into it, I realized it's not as easy to solve this thing algebraically as I thought it would be. But the closer I got to looking at it, and I guess the first thing that came to mind was, okay, these two lines have to intersect on the x-axis. So the first thing that came to mind was, okay, if they're going to be on the x-axis, that means my y value has to be 0. So what I did first was I set both the equations equal to 0. And after I did that, I went ahead and solved both the equations for the common variable x. And why did we want to solve for x? Because if I have two equations that are set equal to the same variable, then ultimately I can set both of those right-hand sides equal to one another. So for the first equation, if we set it equal to 0 and we solve for x, we eventually get that x is equal to negative 5 over a. And for the second equation, we get x is equal to negative b over 3. And now, once again, now that we have it set equal to the common variable, we can go ahead and set those right-hand sides equal to each other, which creates a proportion. And through cross multiplication, we get ab is equal to 15. So what does this mean for us? It seems like we've done a lot of work for not a whole lot of a result. Well, what this means is that the a and b positive integers have to be factors of 15. So the only factors of 15 are 1 and 15, as well as 3 and 5. So hence a and b can be the ordered pairs 1, 15, 3, 5, 5, 3, and 15, 1. And when we look at the x-coordinates of each of these ordered pairs, we come up with the respected ordered pair, or the respected x value to be negative 5, negative 5 thirds, negative 1, and negative 1 and negative 1 third, which ultimately gives us our final answer, a sum of negative 8. So after a little bit of work, this is what I came up with. And then what I typically do is I go to my graphing, I go to Desmos, and I look at the two graphs and I see if they do indeed work. So I already went ahead and typed in our two equations, y is equal to ax plus 5. Notice it automatically makes the slider for this, which is very nice. That's why I love Desmos. And then also y is equal to 3x plus b, and then we have the slider for b. So if we try the first order pair 1, 5, notice on the screen, here we have our intersection point, which is on the x-axis, and it gets us a root of negative 5, or an x value of negative 5. And we can go ahead and check the 3, 5 if we want to. That was our next ordered pair, factored pair that we have together. And if we take a look at it at this point, we have the line that falls on top of one another. Or sorry, the graphs, the lines happen to fall on top of one another, and their intersection point on the x-axis is negative 1 and 2 thirds, or negative 5 thirds. Maybe not the greatest example, but it is an intersection point on the x-axis. If we wanted to, we could go 5 and 3. So we change that, and we take a look at our intersection point, once again on the x-axis at negative 1, 0. So our x value is negative 1. And we could do the same thing for when a is 15 and b is 1, but I think you get the idea at this point. So ultimately, we add our 4 x-coordinates up, and we get a sum of negative 8. And I was not able to find any other ones, and the algebra does make perfectly good sense. So hopefully this video was helpful to you, and hopefully we were able to come up with some common solutions. Thanks.